Ladies and gentlemen, thank you for coming and clicking on my video. I just thought I'd kind of show a little rundown of kind of what I've been working on lately. Um, I've been really impressed with what JavaScript can do in recent history, and I really haven't given it as much. Don't need that. I'll get rid of this file here. I can't really say that I've really done all that much with JavaScript in the past. I mean, I've done some basic little things here and there on web pages, but the idea that you can really use it to prototype and play with ideas is kind of a new thing for me, and it's really cool. So I thought I'd kind of show what I've been doing lately, and hopefully it'll help somebody else. And in the process, we're just going to make a simple little game in JavaScript using Node and Yarn, Webpack, that sort of thing, to package it all up in a nice little concise way, give it some helpers and things like that, because although JavaScript on its own is great, having some of the features that specifically Webpack gives us is phenomenal. It gives us a lot of really good developer-friendly things. So yeah, we'll just jump right in here. All I've done so far is I'm using Visual Studio Code. I just find it 10 times better than all the other little developer things. It's not as bulky as a full-on IDE, but it's also more powerful than your average thing. So we'll go ahead and jump right in here. Let's go ahead and open our command or terminal. You can see here, for at least on Windows, it's control and little whatever that's. It's the control tilde button, but control that thing. And that'll pull up your PowerShell in the folder that you've opened. And if you're not familiar, you can do File, Open Folder, and then just select the folder that you want to use as like your root, kind of like your workspace, and that's what we're doing there. So the first thing I want to explain, Node is a JavaScript runtime developed for server side. So think of it, you could be like a replacement for PHP or Ruby, that sort of thing. So you can actually have JavaScript on the server communicating with JavaScript on the desktop. Creates kind of like a unified code base. It's kind of handy that way. But more importantly, it comes with something called NPM, or the Node Package Manager. And NPM, if you go to npmjs.com, kind of gives you an idea. You can search for packages. So like if you like to do 3D graphics, you can look up 3JS is a 3D library by Mr. Doob. And here it shows you can import it this way, or if you're using NPM, or if you're using Node, like we would be, you can actually import it. Ooh, it doesn't actually say where it's at, but you can import it instead of actually including just the script and things like that. So there's some cool. It's a way to unify all that. So if you've done Android programming, this is sort of like Gradle or Maven repositories, same idea. But we'll actually be using Yarn instead of NPM. Yarn is quite a bit more, well, in my experience, it's been quite a bit more stable. I've had less obscure errors with it than I have with NPM, and overall I just find it way more useful. So we'll be using that. Ironically, to install Yarn, you install it a lot of times via NPM, which I find kind of funny, although they don't actually show that here. But you can do it just npm i-g yarn, and that'll install Yarn globally. So that's that -g. So npm package manager install global Yarn. And you should see something similar to this. It'll have a little bit more because mine's already installed. But and if you want to check, you can just put in yarn space -- version 1.94. That's what I'm on. That's also the stable. We're good to go. If you want to use NPM, you can. Yarn doesn't really offer anything more than NPM. It's just what I'm used to using and what I like using. So if you want to substitute the correct NPM commands, you're more than welcome to. No pressure, no harm, no foul there. But anyway, and then we'll also be using something called Webpack, and this is really what's going to be our big helper. It takes complicated dependency graph information, compiles it all down into one JavaScript file, one CSS file, and then assets. And it also minifies the code for you and does a lot of that. So here's an example. It's showing where you can, there's the code, bundle with Webpack, you do all your stuff you're going to do, and then out it comes, which is great. And then we'll also be using one last thing, which is Webpack dev server. And Webpack Dev Server basically allows you to run a server, so when you save your files, it automatically updates on your web page. It just makes the whole thing a lot simpler. It streamlines the whole process. So this will take a second to get this all going, but it'll make sense in the end. So let's go back to Visual Studio Code, back into our little terminal here, and we're just going to type in yarn init, I-N-I-T. And this is just going to create a project for us. So it's going to ask us, what do you want the name to be? Anything in parentheses means if you hit enter, it'll just default to that. So blocky is fine, version 1 is fine, and description a simple JavaScript block pusher game. Entry point index will do main.js. Doesn't totally matter because we're going to kind of ignore that anyway. Author Daniel Jackson. Private, yes. Okay, save package.json. So what this did was it created a JSON file, which both Yarn or npm will use when we get in here. So that's good. Next, we're going to install Webpack and Webpack Dev Server. We're going to need both of those. So we're going to type in yarn. Oh, hello, yarn. Add Webpack space Webpack -dev -server. And that'll install both of them. Now, we did not do a -g or a --global or anything like that because these are project-specific dependencies. We want to install these for our project. And this will take a couple of minutes here as it runs through and downloads everything that it needs, links it all together. All right, there we go. So if you go into our node modules, this is all the cruft that it gives us. Of course, this is only for development. We don't need all of this when it comes time to actually deploy, and you'll see that. But you'll notice it automatically updated our package JSON file to show the dependencies, which is also handy. The other nice part about this is if I come back in like a year from now and I do yarn install, it'll automatically upgrade all of these to the most recent and give me all sorts of helpful things that way. Okay, cool. So next what we're going to need to do is in our root folder here, we're going to create a new file called webpack.config.js. And Webpack actually has a nice little demo one just to show you what that can look like, and we're totally going to rip it off. So copy, paste, boom. Look at that, it's beautiful. Okay, and we're going to change source index to source main.js. Bundle.js is fine. So we're going to create a new folder. We're going to call this one source. And within source, we're going to create a new file called main.js. And for testing purposes, we're just going to have it put an alert box that says, hello world. Look at that. We're doing stuff. Okay. Now, let's try doing this. Yarn Webpack. Is that how that works? Webpack, one CLI must be... Oh, Webpack CLI. That's right. We need to get Webpack CLI. Okay, so here's a cool thing, too, about Yarn. I'm not sure if NPM does this or not. Here, I tried to run the Webpack, and it said, you can't do that because you don't have Webpack CLI. Which one do you want? And you can just type in Webpack-CLI. It'll automatically install it for you, which is really pretty handy. And basically, we'll be using Webpack, like I said, to compile our source code down to one JavaScript file. Just makes it easier on the client if we were to ever publish this. Okay, let's try running it again. Oh, actually, I think it ran in the background for us. It created our bundle.js. Okay, so this is what it came out with. This is our code all minified and with some kind of, boilerplate stuff around it as well. So in our dist or our distribute, folder, let's create a new file called index.html. And if you press Shift ! It'll give us an abbreviation and generate a little web page for us, which is super handy. We're going to put this to blocky. And in our body, we're just going to create a script tag with a source, which is ./bundle.js. And now we can go ahead and jump over. I'm just going to go through this one. We do Control-O to open. Jump on in to just go to our index.html. Okay, it says hello world. So we've got at least something going on now. So The way to think about this is all that Webpack is doing is taking whatever sources we all link together through this main.js and compiling them down into this bundle.js, which is just a more efficient way of storing the same thing. Now, obviously, in this case, it's such a simple program, it actually adds more than it helps, but you'll see down the road it gives us a lot of benefits. And then index.html is the same thing, but we're going to be developing like 99% of this in JavaScript, not in HTML. In fact, we're going to be doing our styling in JavaScript too, so you'll see how that kind of works. Typically, you won't actually need to mess with this code here, so we'll go ahead and get rid of that. We'll get rid of that one as well. Okay, so the one last thing that we need to do before we really get started here is get our Webpack dev server set up properly. So let's open back up our package.json and create a new line in here somewhere, and it can be any of these as long as it's on this same first level. And we're going to create one called scripts, give it these curly brackets and an extra comma at the end because it's an object, and we're going to do one called build colon, and then in here we're going to put Webpack, and then we're going to do that one that says start, which is going to be webpack-dev-server. And that just gives us some handy little hooks so we can do what we want to do from the command line. You'll see how that works in a second. Now, again, I'm going to totally rip off this I think Webpack actually has in their getting started how to do this. Output, loaders, plugins, modes. Ooh, I forgot we need to change that to development. That'll make it a lot easier for us. Mode. So production, actually I can show you kind of what that looks like. There we go. So if we do yarn webpack, let it run Webpack real quick. Okay. We open up our bundle.js. It looks like this. If we put this back to development and then run it again, we get this, which, there we go, is much more human readable. And so this is nice because we can, here we go, so then it shows here no static exports found, and it gives a little header to show this is when our source starts. So the reason that this is nice is for debugging, but of course it's a bigger file than the other one would be, so that's kind of the difference there. But we'll leave it in development for now. Now what we want to do, okay, so Webpack dev server config. So I don't always have this stuff as memorized as I'd like either, but it's nice to have because everyone else has it for you. So okay, here we go, perfect. So we can take this whole section right here and paste it underneath output. Oh, we need a comma first so we can do another item. And this is dev server specific information. Also, in case you couldn't see what I was doing there, I'm pressing F1 and then format document. You can also do Control Shift Alt F or something like that, but I just get used to it this way. And this will give us some information. We're going to port, let's do 3000. That seems nice. Save that. Now, because in our package.json we created a script called start, which calls this up, we can actually just type in yarn start. And here it's running the dev server. It's compiling everything. It shows all the stuff that's compiled. It says compiled successfully. So now let's go back over here. Instead of opening the direct HTML file, just the one itself, let's do localhost :3000. And there we go. So now if we change something in our file and save it, it restarts and refreshes for us right there. And that's what we want. Now we can get running. So without any further ado, what do we want to do here? Well, the first thing we're going to do is create a canvas, get control of the canvas, start drawing some stuff to the canvas, and then we'll start kind of separating out our code from there. So to start that off, let's go ahead and create a canvas item. So we're going to say let canvas equal document.create element, parentheses, and in the quotes here we're going to put canvas. It just needs a string to know what type. Then we're going to say canvas.width equals 800, canvas.height equals 600, document.body.append child, parentheses, then inside there put canvas. Ooh, not that, canvas. Okay, so what we have done now is we've created a canvas element, given it some information attributes, and then stuck it on the page. And if we go to the inspector, we should see there's our canvas. Of course, it's the same color as the background, which doesn't really help us any, but at least we can see it there. So the next thing we can do is we need to create the context, and that's how we draw things to and from the screen. So let's put let ctx for context equal canvas dot get context parentheses quotes 2D. And then let's do ctx.fill style equals, and we're going to give it, let's see, 303030, ctx.fill rectangle 00 to 800, 600, save it, and there we go. So now we're drawing a rectangle from the inch from basically matching the size of our canvas. Now, there's some things we could do here, and I don't really like how it's got all this white on the outside edge. You know, for our game, we don't really want to do that, but for now, we'll leave it. We'll come back to it later. Okay, so we can now draw. That's great, wonderful, so glad we have that. But it's not dynamic. It's not doing anything right now. If we come in here, I mean, there's no interactivity whatsoever. So let's try creating our character. Let's just be our little player. So we're just going to say, actually, we're going to put it up here. Let player equal, we're going to create an object. If you're not familiar in JavaScript, this is one way you can create an object. You can put these curly brackets and then put attributes within here. So we're going to say position is going to be an array, and it's going to be at 50, 50, x and y. And then we're going to say color. Well, no, we'll leave the color. So we'll just say that for now he just holds position. This could just be an array, but we're going to actually keep it an object so we can add more things to it later. And now we're going to say, okay, so we've filled in the background with this gray color, it's dark gray. And now we're going to draw our player. So we'll say ctx.fill style equals, and we're just going to say green because we're simple. ctx.fill rectangle at position. So we're going to do our player dot position at index 0. So that's our x. This is our y, and it's going to be 50 by 50. That's going to be its width and height. And there's our little player. So here you can see we've got the fill rect control, and actually it shows it there, which is nice. It shows that our x is a number, y is a number, h, or w and h are numbers, so that's our width and our height. Now, the only downside of this right now, if we actually take our position to 0 and 0, you'll notice we're just in the corner. So it's actually measuring us from our upper left-hand corner. If we wanted to fix that, we can do our position minus 25 and position minus 25 and keep the width and the height the same. Now it's centered up. And personally, I like that. Let's just go ahead and parameterize that. So let's do size. It's going to be 50. So now we can say that the x position is, here we go, we're going to make this a little bit better here. Its width is going to be player.size, height is player.size, and then we're going to offset it by player.size divided by 2. There we go. So now if we go to 0, 0, 0, we're centered up there, and if we go to 50 and 50, we're centered on 50 and 50, which would be cool. Okay. So, except, you know what, if we're operating on a, I just realized now, this seems like a silly thing, but if we're going to be working on a grid, it might actually make more sense for us to not do it that way. Kind of figures, doesn't it? Okay, let's just get rid of both of those. Save. Okay, we'll just do that. So we're going to say we're on a 50 pixel grid. So if you imagine splitting this 50, and you know, each one is 50 pixels, each one this way is 50 pixels. In fact, we can visualize that very nicely. I'm going to take a screenshot real quick. There we go. We'll let GIMP load up here. Yeah, we can visualize that in GIMP. This would be a good way to show you kind of what we're looking at. So we can Control V to paste that in. Let's go ahead and crop this down to size. Auto shrink. Okay. So now we can say, I gotta find where it's at here. Configure grid, no guides. Here we go. View, show grid. What a beautiful grid we have there. Edit. I gotta remember where the grid settings are. Image, configure grid, here we go. Solid, that's fine. Horizontal spacing at 50 and 50. Yep, there we go. Okay, so this is kind of our grid that we're operating now on. So you can see how we've got all that. So that's cool. That's basically what we're running in right now. So now let's work on, now that we have our character, we have him rendering, that's great. Let's work on some controls. So we're going to do some controls up here. Where do we want this to be? Let's put it here. So we're going to say canvas, canvas dot on key down equals, and then we're going to parentheses EVT for event equals, and then the greater than sign, open curly bracket, close curly bracket with a semicolon at the end. This is just an arrow function. It's for what we're using it for. It's basically the same thing as saying function parentheses yada yada, but this makes more sense in my head, so that's what we're doing. So we're gonna say is key down. So now let's do console.log event EVT. And this is a great way to prototype, because now when I come over here and I press a button, we get nothing. I wonder why that is. Gotta love when somebody says something that's how it works. Looks like we can use document. Why can't we use canvas, I wonder? Does it matter that it's been appended to the document already? No. Okay, well, we'll just use document on key down. That's fine. It's really, that works the same for us. So here you can see we're getting it printing out the object. So we can use the key, the character code, the key code, whatever we want to do. Technically, key code is the best way to do it, but I like character code better because it's easier, and we're not making a full-on game right now. So let's just say if evt.key is equal to, we'll say the D character there, then we'll say player.position of x plus equals 1. That doesn't look very impressive, does it? No. But that's okay. I'm actually wondering if this needs to be up here. I was hoping it would be. Okay, let's do by 10. So obviously I'm doing something wrong here. Key down, key equals D. So what am I missing? We'll try that. Key dot code equals key D. Oh. Okay, so I feel silly. The whole reason I was skipping the step was to show you guys this is why you don't want to skip this step. And I got myself caught. Okay, so the reason it's not updating, although it is actually updating, because in fact, if we were to log out the, here we go, let's try this to show, console.log player.position, here now we'll be able to see the player's position. You can see it's increasing by 100 every time we press the D key, right? And in reality, we're going to go by like increments of 50, right? Because we're going to go by bricks. And let's create another one. Key A minus equals that. So now we should see, oh, actually that needs to be position 0, not 1. Silly, silly. So here we can see 50. You can see it going down by 50 every time. And coming back up by 50 every time. There we go. Okay, so that's great. But nothing's happening, and that's because our script is running all the way through setting a listener for that, rendering, and then being done. That's obviously not what we really want. So how do we fix that? Well, we need to create a rendering loop, and so we will do that. There's about a million different ways you can do it. I'm going to do it this way. We're going to say window.request animation frame to loop function loop. And we're going to put this whole thing inside the function called loop. Format my code a little bit and see if that makes a difference yet. Not yet. Okay. Oh, because we're still only requesting once. So then at the very end of all this, we're going to request the animation frame again. And now we have movement on our grid, at least left and right. So let's go ahead and create the forward and backwards motion as well. Just kind of cleaning up the code a little bit here. Okay. So we're going to do W and S. Positions 1 and 1. Let's try that. And I got W and S backwards. Okay, that's fine. So S and W. There we go. So now you can move around on our little grid here. But of course there's no bounding or anything, but we'll come back to that later. So we've now got enough going here. I think it's time we go ahead and start splitting some of our code out, start making things a little bit less confusing. And you'll see why we want to do that in a minute here. So let's go ahead and create a new file, call this one player.js. And we're going to say export default. There we go. Class player. Okay, constructor. And really there's a million ways you can do classes and stuff. I really like this sort of class structure just because it's what I'm used to. I program a lot in Java, I do a fair bit in C++, and it kind of, this feels nice to me. So we're going to go with this. We're going to say this.position equals an array at the starting position of 0 and 0. This dot well, yeah, we'll just do that for now. Okay, so now player we can get rid of. Well, we won't quite get rid of him yet. You'll see why. We're going to create a function called move. And it's going to go an x and a y. We're going to say this dot position of actually dot x, because we're going to create. Let's make this like an object. See, we're getting crazy here already. An object. We'll say x equals 0. Y is also 0. So now its position is actually an object with an attribute x and y, just to make things a little simpler for ourselves. Plus equals x, this dot position dot y, plus equals y. Okay, so now we can rewrite this. We need to import or include this. So let's go back to the top of the script here. We're going to do import player from /player. And then we're going to say player equals new player. Okay, so now we've created a new object, which is our player. And then we're going to create, let's create a function in here called draw. And it's going to take in a context. And this will be just the player specific code. So we're going to say ctx.fill style equals green again, because green is for good guys. ctx.fill rectangle at position this dot position dot x, this dot position dot y, and the size of the grid, which is 50 and 50. And then we'll say in here, instead of calling this code, we'll just say player dot draw and pass in context. And there's our guy back again. Now we don't have any movement, but that's okay. Instead we say here player dot move an x of 50, y of 0, and on the x of minus 50, this one is going to be the y of 50, and this one's going to be the y of negative 50. Let's try that out. There we go, we got our same exact code now running, but everything's kind of compartmentalized now. So our player is all over here on his own, which means we can do all of our functions, all of our processing on the player in a separate class. It just makes it easier to see. Now, here's where it comes in handy with Webpack. Let's go ahead and cancel our thing here. Control C, hit yes to that's fine. And now let's do yarn space build. Whoops. And it's going to package up all of our code for us. And if we go into our bundle, you can see here we have our, this is our main.js file, this is our player file. And if we take this and turn it back to production, and compile it again, let it do its thing, here we go. There's our code all streamlined. It'll be quicker to download, easier, and all that kind of stuff. So that's why we use that, or what we use that for. But honestly, the most useful thing that I have for it is just the fact that is the fact that we can use it to prototype quickly. Okay, so now we're back up and running. We can verify. Yep, we're working around. That's fine. So the next thing that we want to figure out how to do, or that I'd like to figure out how to do, I'd like to draw the grids so the player can kind of see where they need to go. So that'll kind of end up being incorporated into like a world object at some point, but for now, let's just hard code it in. So let's just make a little thing here, and I guess it should be drawn before the player and everything. Yeah, we'll do that. So before, draw a grid. Okay. So now, and here's where it's always good to be able to look up. Let's see, we'll do canvas draw lines. Line 2, okay. So this is something I like to check just to make sure that I'm in the right place here. So, okay, begin path, move to line 2 stroke. Okay, that's easy. So what we'll do then is we'll say ctx.move, dot begin path, ctx.stroke. We'll just do that to kind of give us our two starting and end points. And then we'll do ctx.move to, and we'll say 50, 0. ctx.line to 50. We'll just say 1,000 because that's fine. And stroke. There's our first line. Okay, cool. So that's working. Let's put that inside of a loop so we can just loop across the whole page there. So we'll say for, actually we'll say for, well, we'll do this. Yeah, we'll do this. For I equals 0 while I is less than, let's do some quick math here. We got 800. We're dividing it by 50 chunks. So 16 chunks total. So while it's less than 16, I plus plus. Okay, I'll just, oh, yeah, well, okay, fine. Let, there. So now we're just drawing a bunch of lines in the same place, but we can actually take this left guy here. Ooh, not 6D, we want 16. And instead of saying 50, we're going to say I times 50. And there we go. There's our horizontal. And then we'll draw our vertical, which will be that same math. Actually, instead of doing it that way, we could actually make it so it does automatically. So we'll say canvas.width divided by 50. That way it figures out the math for us, and if we change the size of the... Yeah, there we go. So now I'm doing one for the height. We'll still let I do the same thing, but instead of doing that, we just literally change these over. So we'll do that. There we go. It's beautiful, isn't it? So now we have our nice little grid. You can see we're moving around on it. That'll just help for, if nothing else, debugging. And our players there. If we drew the player before the grid, it really wouldn't change too much yet. Just it would only be a pain if we get further as we get further along. So we'll keep it this way. Okay, that's pretty easy. So the next thing we're going to want to do is create some way to create a block, and then be able to push that block around. So let's make a new source file. Call this one. Well, do we create one block? I'm trying to think organizationally here. We could create one block that all the block types inherit from that has certain features. That'd be really handy. Yeah, let's go ahead and do that. So block.js and export default class block. And there are going to be certain things that every single block has, and that's kind of what we're trying to sort through here. We're going to take in a position, which is going to be an X and a Y, and we'll say this dot position equals X is going to be X, Y is going to be Y, and then we'll say this dot color equals I wanted to make a random color, but you know what? I think I saw, let me look it up here. I saw somebody had a really clever way of solving this. JavaScript random color. I think I saw somebody had like a really cool way of like, yeah, here we go. I like this one. This is cool. Boom. So basically it just creates a hexadecimal string, prepends it with the hash sign on it, but it randomly picks those. So I don't 100% understand this, to be totally honest, but it's cool. So this will give us a random color for our block. And then every block's, really, its rendering can be the same pretty much, at least for now. We can always override if we need to. So we'll do a new function called draw, which takes in context. And then we'll say context dot fill style equals this dot color ctx dot fill rectangle from position of this dot position dot x, this dot position dot y, 50 and 50. Okay, so now we've done that. We can go back over here, create a new, whoops, here we go. Let block equal new block. And you can see when I did that, it actually automatically imported that for me, which was really handy. And then we'll say down here, block.draw ctx. Of course, the problem right now is that it was expecting me to give it some values as far as its x and y positions, so we'll say 200 and 200. And there's our block. There he is. Of course, we can go through him right now, but you'll notice he changes colors every time we run him, which is kind of fun. Okay, so the next thing we're going to need to figure out is, can a block be moved or not? And so we're going to need to have a value for that. So let's say this dot static equals false. Let's do true first. Okay, so we'll say this is true. It's static. We're going to say if it's static, it's like a wall. Otherwise, it's a block, meaning it can be pushed around. We're going to keep the random color because I like the random colors. I think that's kind of fun, kind of goofy. Okay, so now we're going to do... So we need to figure out whether or not we're touching the other character. And basically the way to look at that is if we measure from... There's a couple ways we can do this. One is if we measure from this point to this point, if that distance is ever less than this angle here, or if it's ever less than 50, then we're touching. And that's really doing the math of a circle versus a square. But since we're working on a grid right now and everything's locked to this 50 by 50 grid, I think that's more than okay. I don't think that's a problem at all. So what we're going to do is we're going to create one more class called util.js, and we're going to create a function, we'll create a class. So export default class util static distance. Actually, we'll just do dist, because we like abbreviations. They're cool. And it's going to expect an x from the first position, a y from the first position, an x from the second place, and a y from the second place. And it will hopefully return to us a distance of how close we are to that thing. So if you remember Pythagorean's theorem, a squared plus b squared equals c squared. So in order to figure out how far apart these two corners are from there to there, we need to do some math to figure that out. So let's do it real quick by hand, just to show you how it works, and then we'll come back to it. Yeah, we can do that. Ooh, let's turn off our grid now that we got our own grid. That's going to be confusing. Show grid off. Okay. It's going to bother me if it's not lined up. There we go. That's nice. Okay, so here's what we're trying to solve. Here's what we're trying to figure out, basically. We want to know how far it is. Let me create a new layer here. We want to know how far it is from that point to that point, right? So how are we going to solve that out? I wish I had picked a color other than... There we go. So from there to there, how are we going to figure that out? Well, Pythagorean's theorem is going to come in very handy because we know its position. So we can figure out the distance there. So for example, if we draw a line straight down here and go from this corner and we draw a line straight over here, and then we draw, we're going to use a different color because we are cool like that to connect these two together here. There we go. So this one is called the hypotenuse. Wow, I can't draw with a mouse. That's terrible. And this one's going to be A. Actually, let's make it yellow since we did it in before. A and B. Okay. So each side, each leg, each yellow part there is one of the legs. And what Pythagorean's theorem says is that if you add together the squares of both of these and then take the square root, you'll know the distance here. And that's really what we're trying to figure out, because if that distance is ever less than one unit set, which in our case is 50, then we're colliding and we can't do that, right? So here's what we're going to do. First, we're going to just break it down into big, nasty variables, and we'll streamline it later. So we're going to say let leg 1, we're going to say, actually we'll say A equal x2 minus x1. So that gives us, let me pull this back up again. So if this one, let's say its position is, we're going to say this little point here is at 10, 10. I'm literally just randomly picking a number here for that point. And then we'll say this other one over here is at 10, 20, 30, so 30, 20, 10, 20, 30, 30, 30, I guess. Yeah, 30, 30. Okay, so we'll say that this other point down here is at 30, 30. So if we take the second one minus the first one, it gives us 20, which means that's the distance here. And sure enough, we have 10, 20. So that's 2 units there. So that's our A. And we do the same thing to create B, but we're going to use Y. And then we're going to say let A2, which is A squared, equals A times A let b2 equal b times b. So we have a. Now we have leg squared a and b squared. So we have both of those, and we need to add them together. So we'll say let legs equal a2 plus b2, and then let h for hypotenuse equal math dot square root of legs, and then we'll return h. Okay, so we created a lot of variables that we're not going to need, but for the time being, this is going to make it easy for us to prototype and see what's going on. So let's go back to min.js. We're going to go to, yeah, see, this is the only downside. I got to figure out how are we going to, well, I guess we'll get to that when we get to that. So for now, let's just put in the loop. We want to say every time that we loop, let's draw the distance between the two. So we're going to say util dot distance from player dot position dot x, player dot position dot y, and then we're going to say block dot position dot x, block dot position dot y. And now with a little luck we should start getting, oh, I didn't log it or anything. Let's see. There we go. So that's our distance right there. And as we move left and right, you can see how we get closer and closer and closer. And the closest we should ever get is 50. But it doesn't matter which direction we go, 50 should be the lowest we ever get. When you get down to 0, you have problems. So there we go. That's actually not too bad. We're doing a pretty good job there. So that distance function is going to be super, super handy for us. So let's go ahead and get rid of that. Now, this is where I want to figure it out a little bit better. So let's try this. We're going to create a list in the main world here of blocks. So we're going to actually get rid of that. We're going to say let blocks equal, and it's going to be an array. And then we'll say blocks dot push new block. Ooh, here we go, block. Position 50 and 50, or I guess we'll do 200 and 200. There we go. Okay, and then we'll say here blocks dot for each block goes into this arrow function, and then block.draw. Okay, right back where we started now, but that's good. That's where we wanted. So all we're doing here is we're creating a list of blocks. Instead of just having one block, we can have as many blocks as we want, and they will populate as we go. And this means we can do the same operation on all the blocks at once and save ourselves a little bit of hassle. So now we're going to try to see if, okay, player.draw, yeah, that's fine. So each one of those will draw there too. So now what we need to do is we need to draw the block, but we also need to figure out, are we touching the player? And if we are touching the player, which direction do we need to go if we're being pushed? What direction does the player need to be put back if we can't be pushed, if we're static? So how do we want to do that? This is all real time, by the way. You guys are seeing me solve the problems out as I go. Oh, real quickly, let's go ahead and fix this up a little bit. Quick thing we can do, nice and easy, add parentheses around these two. We'll grab them both, substitute them for A and B in this one. Now we can take this and do that. That should be the same as order operations says. We're going to do things in the parentheses first, then multiplication, addition will come later. But we can verify that by console.log util.distance. I shouldn't have deleted that, should I? position.x, player.position y blocks of 0 dot position dot x blocks position 0 dot position dot y. Whew. Okay. Still working. Okay. Cool. And then we can go in here, and now we can take this whole thing and slap it inside there. Verify it again, just make sure it's still working like we want. Yep. So that means we can actually take this, and we now don't need any variables. We can just do it all in one go. Makes it a more efficient function that way. Oh yeah. Okay. So now we need to figure out how to handle this. I'm going to handle this actually from the player's perspective. I'm going to hand the player a list of blocks and have him check through all the players to see if he needs to move or not, and we'll go from there. So we're going to create a function, player.update blocks. It's going to need a list of all the blocks. So now let's create that function, because now it's going to go, oh, hey, there's no such thing as that. So we're going to create a new function here called update, and it's going to take in a list of blocks, and we're going to say blocks.for each block that goes into this function here, and we're going to say if distance, if util.distance between this.position.x, this.position.y, block.position.x, block.position.y. Okay, so if that whole thing, if the distance is less than okay, so here's the thing. If we're at 50, we know we can't go any further. So we'll say, okay, let's always store our last position. That's what we'll do. This is not the most efficient way to do it, but I think it'll actually work well for us. So last position equals that. And we're going to say, okay, so we'll do this. We'll go ahead and will we ever move more than that? That's my question. So we really should move that input stuff into here, shouldn't we? That would actually make more sense. Okay. Well, we'll get back to that in a second. So let's see. So the player moves. Okay, so what we need to do is we need when it goes to move, we want it to check. Can I actually move the direction that it wants me to? Or is that going to cause problems? So, see, that's where I'd rather not. Okay, let's be preemptive. I'm changing my mind on this. We're going to be preemptive here. And we're going to say, in the constructor, you need to pass me the blocks. You need to tell me where the blocks are. So then we'll say this dot blocks equals blocks. And because JavaScript passes things by reference, as we update blocks, this should also get updated, which is nice. So then what we'll do is we'll say whenever we go to move, this is probably not, I don't know if it's any faster or not actually. We'll see. We will see. So we're going to say whenever we go to move, we're going to then we need to go to where we're going and then try. So we'll say let target position equals So basically what we're saying here is that this is where we'd want it to be if all goes well. So now we can say, we can check that against the other. And you know what, actually I'm going to change this, so instead of taking in those kind of variables, it's just going to take in vector 1 and vector 2. And then we're going to replace x2, so find x2, we'll do x1 with vector 1.x, y1 is going to be vector 1.y, x2 is going to be vector 2.x. So I'm just changing this up so that I can use, you know, this sort of pseudo vector math that I've created, just to save me some. Oh yeah, see, I've actually made that more complicated now, didn't I? Way to go. Okay, so vector 2.y, vector 2.y, not a number, it's a, oh, because we're still passing it different things. That's fine. So now, instead of having to type in all this craziness, we can say player position and block position. That's a whole lot cleaner. I like that a lot better. Okay, so let's go back to our player now. Okay, so what we're going to do now is we're going to see, let's just check for both and we'll see if we can get away with that. So we'll say then if utility dot distance between position, this dot position, and whoops, I'm sorry, I want target position and block dot position. So then we'll say for, let's see, blocks dot for each. Okay, so what we're doing now is we're telling it this is where we want to go. So now for every one of the blocks in the scene, let's see how far we would be away from it if we were to go there. So if all of that, if that distance is greater than or equal to 50, so actually I want to say if it's less than 50, no, if it's greater than or equal to 50, then we'll say, okay, position equals target position. Okay, let's try that. So now this dot blocks is undefined. Ooh, it doesn't like that, does it? Wonder why the blocks would be undefined. So let's look in here and see. In move line 22. It may be because we're, no, that should be fine. Okay, so this dot blocks. So something about that blocks is not. Oh, we never passed it the blocks, did we? When we created the player. Here we go. Blocks. And we'll go ahead and just put that down here. Okay. So now we can move around, and sure enough, it stops us if we try to go into it. Okay. Getting somewhere now. So now we can't go into it. Okay. So now what we need to do is figure out, we need to query and see, is the, yeah, let's go ahead and get rid of that. Now that we're actually using it, we don't need that code there. So the next thing we need to do is figure out, is the block that we're trying to push into, is it static? If it is static, great. If it's not static, meaning it can be moved, we want to move it instead of moving ourselves. So what we'll do is we'll say this dot static equals true. Let's do this, math.random greater than or equal to 0.5. So now to give us a true or false randomly. And console.log static. So now it'll tell us if it's static or not. So we get false, false, true, false, true, true. Okay, so we can jump back and forth sort of randomly just by restarting the page, which would be nice. So now I'll come back into player, and we're going to say for every single one, if we're within that distance, if we're not within that distance, we just keep going. It doesn't really matter. Else, meaning we are within that distance, if block dot static, is it just static or is it static? It is static. Okay. So if the block is static, actually, we'll say if the block is not static, then we'll say block dot move X and Y. So we actually want to take the movement we were going to apply to the player and instead apply it to the block. So, okay, yeah, block move is not a function. That's fine. So let's create one. Move X and Y. And for now, we'll just do a basic, you know, this dot position. Actually, we'll go ahead and create the temp one because we're going to come back and fix this in a minute. There's going to be some things that need to change for this to actually work the way we want, but that's okay. So we'll say position equals target position. Okay, let's try that now. So static, it's not moving. For when it's false, okay, and there we go, we can push it around now. But really, we should move with it when that happens. So let's go ahead and say, and if that happens, then we'll go ahead and also go ahead and move ourselves too. So if we do that, it's static. Now it's not static. There we go, we can move this little block around now freely as we wish. Now the trick part here is we're going to need kind of a feedback loop, because there could be a case where if you have, for example, a static box here and you push against it, it needs to be able to communicate back to the player and say, yeah, but I can't do anything anymore. And that's going to be a little tricky, but we'll worry about that in a minute. Okay, so now let's try this. We're going to try to make one. Okay. So now let's create a finish line block, a block that you win if you can get to this block. So we'll say new file, call this one finish block.js, export default class finish block, extends block. It's going to import that as well because it needs it for its, so it can know what to do. Nothing else is going to change about this except we're going to take over the draw command. Well, yeah, we're going to take over the draw command, ctx super.draw ctx, but we're going to make it just flash like crazy so it just loses its mind. We're going to say that we're just going to reset its color every single frame. So whenever we create a finish block, we'll just be doing that. So then we'll say over here back in main, let's create a new finish block. New, I'm going to add another block to the system here. Finish block, position 600, 300. And there it is. It's just going berserk. Look at it go. Okay, and then we'll also say constructor X and Y and movable. Is that with an E? I don't even know. Okay, so we'll say static equals movable. But we'll say, ooh, here we go, static. That's a better way to put that, isn't it? That was really bad. But static will default to true. Something it does not like there. Oh, okay. Is static equals true. Okay, so it'll default to it being static then. Oh, why are we not stopping? Okay, let's see. So we're smaller than that. We go down here. If it's not static, we go ahead and we move the block and we take our position. Otherwise, we just continue on as if nothing happens. So why? Something is funky there then. Is it just that we have the 2 in it? If we just get rid of one of those, then do we go back to the normal functionality? Oh, that's interesting. Okay. So what we need to do is we need to say if we find one that doesn't let us move, we don't need to really go any further. Is that right? That seems wrong. Okay, let's look here. Let's see what's our problem here. So we say we want to go here. We go there. Okay. So we keep going, and if so we need to do any of them. So then we'll say okay. Let should move equal true. And then we'll say if it's less than 50, which is the only case. There we go. Then if that's, let's try that. Oh, it's not liking that. Something is gone funky. Okay, we'll go this in a second. Okay, so should move equals true. We'll come to the very end here. So if should move, then position equals target position. And then we'll say here if the player is within the distance. If it's not static, do that. Else should player move equals false. It's not doing a great job at that, is it? Should move equals false. There we go. Okay, now we're getting somewhere. Okay, cool. So now we need to... Okay, so we want to create random blocks. We also want to put the finish line or the finish position in a random place. So we need to find a way to randomize that. And I think the thing we want to do is change this so that instead of each of these being grids of 50, we treat them as individual pixels almost and let it fill in the rest. So I think the way that we should do that is instead to say, in our main file here, we'll create an actual variable. So we'll say constant scale equals 50. And now we're going to use scale for everything that would normally be of 50 or whatever. So, for example, the player... Okay, that's all fine there. Oh, that's good. So we're only going to move in one position, one position, one position, one position there. It's going to be that divided by scale. We're going to move by that by scale. So every time we see 50, we're going to replace it with scale, basically. And then in our player, we will also do the same thing. So we'll say, we also need to just pass in the scale. So scale and the blocks, and we'll say this dot scale equals scale. And the reason that that's going to be really helpful is because we need to know so we need to know that our position times this dot scale, and we want to be the size of this dot scale. Try that out. Oh, didn't like that very much, did it? This dot blocks undefined. Okay, yeah, because we're still So we'll say scale. Okay, we're still moving around like we were wanting to. This is good. So basically, we're storing all of our information in regards to what cell we're in now, and we're just multiplying by 50 to get the actual that amount there. And the nice part about that is if we say let scale equal 50, so we can change it. We say, like, if we want part of our game to be every time anybody presses a button, scale minus equals 1. Well, then as you move around, scale. Come on. Every time you move, the world changes sizes a little bit more and more and more and more, right? So that's kind of a cool little, and because everything is, and then it freaks out because we've gotten down too far. We did not like that at all. So we might want to make sure we don't ever get it to a negative number. Yeah, I hadn't really thought about that one. Okay, so the problem we have here, though, is I noticed that our guy is not actually updating with it. Which, I mean, isn't really the end of the world. You can always have it in the draw function, update the scale. That might not be a bad idea, but like if we did scale here instead, and instead of doing this dot scale, we'll get rid of the this dot part. Oops. So we use our local copy of scale instead. And then when we come back in here to draw, we say scale. There we go. Now you can see we're staying in the grid and we're actually zooming out as it goes. So, you know, you could use that for like a zooming feature or something like that. You could also say, like in the main loop here, maybe do scale minus equals 0.001. And so it automatically will start scaling down. Maybe we go a little faster than that. There we go. You can start to kind of see it going there. Maybe that's part of your gameplay, is like you have to get, you know, away from water, but you go too fast and then you're gone. Oh, wait, no, restart. Again, though, you gotta be careful not to let it go too far. So, okay, so we'll do that. You could also do, you know, if you wanted your scale, but I'm gonna do mine constant because there's no reason to change it. 64 is nice too. You know, you can do 32 is always fun. It kind of fits that grid a little nicer there. We'll go with 50 for now again. Okay. And now we'll say, so instead of being at 200 and 200, we're going to go 1, 2, 3, 4. So we're going to say it's going to be at position 4 and 4 and 5 and 5. So now they're all bundled up on top of each other, so we need to change our draw. We're going to say scale. We're going to use the scale here, position.x times scale, y times scale, width and height are both scale. Here we go. Okay, so then we'll say 4 and 5, 4 and 5. When we go to draw it, we're also going to pass in scale. It's not liking that a lot, is it? Oh, it's because our finish block is taking. Okay, so scale, CTX, scale, CTX. There we go. Okay, we're getting somewhere now. So the next thing we need to do, though, is we need to figure out, we need to do the math to say it's not if we're closer than 50, it's if we're closer than 1. There we go. Cool, so now we got our movements that way. The only difference we need to say is if we go and we touch the finish line, if we touch the finish line, and how does this go? If we touch the finish line, then we want to say you've won, congratulations, you win a shiny nickel. I don't know. Okay, so we'll say block to move that. Otherwise, should move equals false. Otherwise, and then we'll check here. If block instance of, let's see, actually we'll say block dot is finish alert, you win. Okay, so we'll come in here, everything's blocking fine, that's doing great. Okay, so now in the finish block, we'll just create a little thing in here. This dot is finish equals true. Now if we burn into this guy, nothing. That guy, you win. Okay, so hopefully that makes sense what I did there. I just created a little attribute on this object called isFinish, and I set it to true. Anything else is going to return back either undefined or false. So by checking to see if it says isFinished, we're saying, are you an object that has this attribute? It's not the perfect way to do it. Another way that I think we could probably do is to say block instance of finish block. I think that would work as well. Yeah, so we can see if it's one of those. But if we do it this way, we don't have to import. We don't have to import the finish block type. We can just check it against as an object itself. Okay, so the next thing we need to do is generate the finish line randomly within the boundaries of the world. And I always like the thing when you did, like, if you ever played like some of the worm, like snake games where you go up and all of a sudden you zap to the bottom of the game and then this you can zap over there. I always thought that was really fun. So I think I might implement something like that. But let's go ahead and first say okay. I'm going to create some other variables here real quick. Just to, so I'm going to say constant blocks x equals canvas dot width divided by scale and height. Oops. H-E-I-G-T blocks y. Constant. Oh, actually, this would be even better if I did it this way. X is going to be that. Y is going to be that. That. Oh, goodness. Okay. Block size. Okay, so now we have some handy little helpers to tell us how many blocks there are side to side and top and bottom. And we can use that to say... Sorry, I'm fixing this real quick. So the reason I'm changing these all to variables is just so that if I change something, it doesn't ruin the whole rest of the game. Okay, so that's all fine. So instead of saying here, canvas height, the width, we'll just say block size dot x, and then here we'll say block size dot y. Cool. Okay, we're getting somewhere. Good has been done here. I'm going to change the way we're rendering this real quick. I don't like that it's flickering so stinking fast. So instead of using request animation frame, which is more efficient, because we're doing such crazy low whatever, we're going to do instead window.setInterval, and the function is going to be the loop. And then we're going to say it's going to be at 1000 divided by whatever frames per second you want. So I'm just going to do like 25. And then tell it not to request the animation frame anymore. And now we're running at 25 frames per second, basically. Locked. So if we do this down to like 5 frames per second, you can see it's kind of like an old school. Kind of has an old school vibe to it. Kind of chunky, kind of slow. I kind of like it personally. So let's go to 10 frames per second, see what that looks like. It's too. I feel like that's too fast. I don't. Go back down to 5. The only thing here is you can feel lag in the inputs there. That's kind of a bummer. Ooh, but here's what we could do. Okay, so we can put it up to like 10, which I think feels better. And then we can go into our finish block and have it have a little counter. Constructor. Oh, I gotta pass the super on, don't I? Super. XY is static equals true. And then we'll say X and Y. We can do that. And then we'll say when we do that, this dot count equals 0 if this dot count is greater than 4. Go ahead and do that, and count equals 0. Now it should, yeah, there we go. Now it refreshes slowly. Much better. That'll give us enough to go 20 frames per second. There we go. I like that a lot better. And boom, you win. You the best. Cool. Alright, so we are much, much closer. So what I'm going to do next is I'm going to have this. So the problem is every block kind of needs to check against every other block in the universe with a force proportional to the product of their masses, and inversely proportional to the distance between them. Okay. So now we've got that guy going there. Let's go ahead and create the random part of it. So we're going to say, do we want a random number of blocks? No, let's do a standardized number of blocks. We're going to say for let I equal 0, while I is less than, we'll say 50 blocks for now. I plus plus. And we're just going to add 50 blocks at random locations. So we're going to say it's going to go to math.round, round, math.random times block size dot x. Okay. We're gonna break this down so it makes a little more sense, hopefully. And then the same thing here, but with y. But y, papa. Okay, so what we're doing, there it goes. Look at that. It's a beauty. That's pretty cool, actually. Let's go down to 15. Yeah, I don't want it. Okay, there we go. That's pretty nifty, actually. I like that a lot. There we go. So what we're doing here is we're just basically saying pick a random number. Math.random always presents you with either 0 or 0 to 1, and it can be any floating point between there. So you multiply it by the highest number that you want, and then you round it with math.round to get a whole number. So we're getting 0 through whatever the width of that was, 16.0. So it could be any, it'd be 14.32145. So since we're doing this in whole numbers, that would be a problem. If actually, I can show you what happened if we got rid of the math.round. There and there. All of our blocks get offset. They're random, but they're not aligned anywhere at all, which is a problem. So the only downside of this, of course, you could have multiple blocks in the same, like sharing the same place or whatever, but it's whatever. Okay, and then we'll do the same exact thing for our finish block. And say he gets to randomly pick as well where he wants to, where he's going to be, and so the goal of the game is to get to him. Okay. And then we'll say finally math.random is greater than 0.5. So this, we're asking a question actually. This is more like an if statement. We're saying if the map.random, which again is between 0 and 1, is bigger than 0.5, then we return a true, otherwise we return false. And then in our block, instead of choosing a random color, I think we should tell it is static. If it is static, we'll say it's red. Otherwise, it's blue. So now the static ones are red, the non-static ones are blue. So if we come over and try to push this guy, it's not going to go. But if we try to push this guy, it will. And we haven't tried together. I think, yeah, they just combine. They just smush into each other. Yeah, that's a shame. But you can win there. Okay, so that's pretty cool. So I think we should try making one. Okay, here's what I think we should do. I'm going to grab this whole chunk of code right here. And here we go. Initialize. No, come on. Fine, startup. We'll call it startup with a size of 15. Now we're going to create a function down here called startup with a size variable. And then we'll say this is going to be going there. Okay, and then we'll say, yeah, these should be out here. Yeah. Yavo. I'm kind of getting a little ahead of myself here. So what I'm trying to do now is make a difficulty selection. So you can choose where you want to, how difficult you want it to be. And since we always start off in 0, 0, well, we'll worry about that later. Okay, so we've got this little guy now. You can push around the blue blocks. You can't push around the red blocks. They're static. Well, we kind of seem to jump through almost, but there we can kind of combine them together. You can even actually smush them together into like super thing, which maybe could be a cool little game mechanic, you know, like where they like get more powerful or something. But okay. Sorry, those colors are really bothering me. I don't like that at all. Let's change those colors. Let's say instead of red, we're gonna say it's gonna be F9 2. Orange is better. Yeah, that's good. And then for blue, we'll do the same thing, but we'll do RGB. So RGB. Oh, I guess I should put the pound sign. There. See, it looks so much better. That's just, that's what we want. I like that a lot better. And you know what? Let's go ahead and take the same color scheme for the player. Oh, where are we at? There we go. But we want R to be there, and we want more red or more green. Let's play with that. What's that look like? Oh, it's kind of nice looking. Kind of a green, more of a green. Yeah, I like that. Cool. Okay, now we're looking better already. This is looking much better. Alright, it is late here, so I am brain frying now. We gotta figure out what to do next. Okay, so we've got that working. That's all fine and dandy. The next step. Oh, yes. Easy, medium, hard, all that jazz. Okay, so let's go into our... Do I want to make the buttons or add them in HTML? Well, that is the question. Let's just make them. We're going to be hardcore. Why not, right? So here we've added some things there. So let's do the same here. We're going to say let easy button, oops, button to Too bad I can't spell. Equals document dot create element type of button. Document dot append child easy button. It did not like that. Bitchy bye. Node not be inserted. Oh, whoops. Document dot body dot append child. So we should have a button. Okay, cool. So now we do easy button dot value. Whoops. Dot inner HTML equals hello. Look at our little button down there. Oh, he's so adorable, isn't he? So cute. Okay, so we'll say easy. Easy button dot style dot font. Oops, dot. No, not fill style. Just style dot size. Is that what I'm looking for? 20 point. I don't know if that's really what I want. No, it's not. I was thinking it was like font size. There we go. That's much more like it. Okay. So we've got an easy button, medium, hard, easy, medium. So just creating 3 buttons and just adding them sequentially into the document should align them somewhat. Easy, medium, and hard. There we go. Cool. Cool, 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 cool. So I want that below our canvas because I think that would look way cooler. So I'm gonna put it underneath the canvas. And it kinda screwed with it, but that's okay. Let's just, before the easy button, let's do document dot body dot append child document dot create element break. There we go. And we could do the horizontal rule. That's kind of fun. Now we'll just do a regular break. Okay, so now we can say that's what we want. We have easy, medium, and we have hard. So now we can just add some button listeners to hit that initialize function for us with different values. So we'll say easy button dot on click, click equals let's try that out. Boom, that was easy. Okay, sweet. We're getting there. So we'll say whenever that hits, we're gonna go to startup with a size of 10. Oh, so it just adds them though. That's a bit of a mistake. So we need to make sure we say in startup blocks equals that. So whenever we start up, it'll clear all of the current ones. Cool. Okay, now we're getting there. So that's 10. And then we can say yodelayhoo. There we go. Start up there. The medium one we'll say has 20. And the hard one we'll say has 30. So we have easy, medium, hard. Except all of a sudden we can go right there. Oh, it's because we're not really getting a... Dang it. Okay, so that means we need to create a way for the player to be updated on that. That's fun. So In that case, we really don't even need blocks or scale here. We just need to update it as we go. So we'll just say, does anyone need blocks? No, it doesn't. So let's just do that. Move that much and give me blocks. And then we'll just directly get blocks from there. That's probably makes the most sense. So whenever we want to move, we then do that and blocks. Means a little bit more code pasting, but that's not the end of the world. That is, though. Well, that's interesting. If you're pushing a block through, you can go through another. Ooh, that's kind of a cool little, like, that could totally be like a game mechanic. Interesting. Okay. Well, anyway. Like there's one comment on here. That's how bad I am at commenting. I don't like doing it. Okay, so then we'll say whenever you win, we need to reload the page, and I think there's a function for that. You win, and then like window dot reload, no dot location equals dot slash. I think that's what it is. Yep, there we go, and then that reloads the page there, and then boop, you win. Of course, it might make actually more sense to be like to fire off a global thing and be like startup 50 or something. I feel like this is gonna error because it's not gonna know what that is. Yeah, it doesn't know where that's at. So we'll just do that, it's fine. Alright, well, I'm gonna say that about covers it. I think that does what we need to do for our little game. There's obviously quite a bit more that could be done. That would be a lot of fun, a lot of cool things you can do. Oh, you know what? I was gonna do the wrapping. Yeah, I'll go ahead and do that. I like that part a lot. That's a cool, fun little bit there. Okay, so when we want to go to move, we do all that. That's fine. And if we can actually move, then we say if this, so say if position dot x is greater than, let's say I don't know what the widest margin is. Do I? Bounds. Pass that in. This dot bounds equals bounds. If this dot x is greater than bounds dot x, then this dot position dot x equals 0. Okay, so now we come back over here, find where we create our player, just give it the block size. Let's see what happens. Okay, so now we need to actually do -1, that way it can jump when we want. So -1. Now we should get a nice, there we go, cool. So that covers going too far that direction. Now let's cover if we're going too near on the other direction. If it's less than zero, then it equals this dot bounds -1. There we go. So there's for our x. Here's for the y. We can just group select all those. Dot y, boom, patom, patom. Oh, that's interesting though. It doesn't like that when I jump like that, does it? That's okay. Call it a win. Alright, well, hopefully you guys learned something, kind of see what I'm talking about. Oh, I'm sorry, before we go, I wanted to show about deploying this, how you actually finish that all out. So now we've got the whole thing working the way we want. Let's go ahead and go back into Webpack. Make sure to put that to production. Save it. Yarn, build. We'll go ahead and pull this up here. Take a look at it. So our bundle.js is 12K. And if we open it with Visual Studio Code, you'll see it's just kind of a bunch of gibberish. But this is all the code that we've made, just straightened, just made more straightforward. And it does all kinds of things like replacing little includes and exports and things like that. It just does it way more agreeably, I guess. You know, some of these I don't even know where they come from, but there it is. And this is a whole lot better than the others. So like if we were to look at, so that's 12K for that. If we looked at our source folder, which is basically what it's taking, it is 5K, 8K, yeah. 8K, but it's over multiple files. So the problem is if you take all these little files, your web browser has to grab every single one. So by combining them into one big folder or one big file, it solves it out. And a lot of times JavaScript won't actually let you include other files like we did. Like for example, if we're in our main.js here and we want all these little things, which I just realized we don't need either of those, all these little guys, we don't need, you couldn't do this. You'd have to physically copy the pieces together, and it's a pain in the butt. Trust me, I used to do it that way. The first couple programs I made in JavaScript were that way, and it just gets to be a pain in the butt. Whereas this, you can literally just send these two files to anyone, and you're good to go. In fact, you could probably, all right, now we're going crazy here now. I'm going to try copying that, and we're going to make a new folder here, super distribution, and in here we're going to create a new file called index.html. We're going to go ahead and create our template again here, and we're going to say script. Let's see if that works. Open, blocky, super dist. Yeah, there we go. So now it's one file, has all the code, everything that it needs, and we got our little game running. I'm doing what it needs to do. That's pretty cool. So here's kind of a fun little. Let's go in debugger, see if what it shows here. Index.html. Yeah, it's like it shows that there's JavaScript there, but it's not really doing much with it. Oh, so here that's cool. It knows that there's a function called distance, constructors, move, draw, constructor, draw, but they just have, you know, single letter names. That's interesting. That's cool. Alright, well hopefully you guys learned something. I'd love to see what else you guys make using this technology, this idea, this concepts, and keep on doing whatever it is you do. I don't really know what you do, but whatever it is, I'm sure it's cool. So keep doing it. Thanks guys. Bye.